Greetings, it's Mathman from another dimension, and today I'm going to teach you parametric equations. Mathman to the rescue. Oh no, Hello Kitty is trapped in the interdimensional vortex. Don't worry, I'm the caterpillar. I am Greg the grasshopper. I will get us out of this dimension. With a little work with the mouse, and presto. Whew, that's a little more like it. This is my environment. But let's take us to our math papers. Whew, welcome back. Okay, so we're going to learn about parametric equations. Here's I was talking about a ball being thrown. Here's the location of a ball. Here's the distance. But what if you said, where is it at 1 second? What if I want to know the x and the y coordinate? How far did it go? And how high up is it? I have 1, 2, 3 letters. Here it is at 2 seconds. Here it is at 3 seconds. How could I get that? I need two special equations, two unique equations. These could be the equations. Maybe you have an equation for x where it says, well, x will be 90 times the cosine of 40 times t. Now, where do they get that? Remember, cosine is the x amount. And 90 was just like the speed they started with. And the y could be its own dimension. What about y? They have this, maybe 6, because maybe you hit the ball 6 feet off the ground when you swung at it. Sine gives you the y coordinate. And what's the minus 16t squared? That's from gravity. That's gravity's numbers. So if you plug in different times, you can get the x and the y coordinate. You have 3 letters. These are parametrics. Let's just look at our equation. Okay, so this is much easier than conics. But you're going to see this in calculus. Sometimes you're going to use a parametric equation. So I say find x and y for t, like time, from 0 to 3. And they're going to give you 2 equations. These are the parameters. X is going to be time plus 5. And I just made this up. Who knows what it is? Not reality. I just made something up simple. And let's say y is 2 times t. Okay, so here's a piece of graph paper, and I make a table. So we're going to do 0 to 3. Let's just go 0, 1, 2, 3. Okay, so now we're going to plug these in. We're going to take these t's and plug them in. We're going to plug them in here, and we're going to plug them in here to get the 2 answers. So let's do x. Okay, so let's go put the 0 in. 0 plus 5, 5. But now put it in here. Put the 0 in. 2 times 0, 0. So your coordinate xy, there's x and y, is 5, 0. So on my graph paper, I'll go 1, 2, 3, 4, 5. There it is, 5, 0. That's it. Time equals 0. You're at 5, 0. Okay, let's do 1 second. We'll do the next dot. I'll do a new color. 1. We'll put in 1, and we'll put in 1. So we'll put it in x, right in here. 1 plus 5 is 6. 2 times 1 is 2. We get the x and the y. 6, 2. So let's see. 1, 2, 3, 4, 5, 6, up 2. Here we go. Here's 6, 2. I should label this here. This was 5, 0. Okay, so here's 6, 2. That's when time was 1. Let's do the next dot. Let's do 2. Plug in 2, plug in 2. Plug in 2. 2 plus 5 is 7. 2 times 2 is 4. We have the point 7, 4. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Somewhere over here. 7, 4. That's when time is 2. If I graph paper, it would look much nicer. And we'll do one last dot, 3. Put 3's in. 3 plus 2 is 5. 2 times 3 is 6. We have the point 8, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 8, 6 is like right there. 8, 6, that's when time is 3. It actually, this one is actually just a straight line. If you were to connect it, the graph paper look nicer, it would be better. But what you're going to do is you can connect it. It is a straight line here. Okay, and in addition to connecting it, you have to say which way it's going. We started at 0 seconds and we ended up here. So we put an arrow to say the direction go. In fact, people like to put an arrow on each dot and say we were here, then we went here, then we went here, then we went here. So this says we started here and we ended up here. And that's it. That's how you graph a parametric equation. So pretty cool. They could give you all types of equations. I'm going to show you one right here. Look a little more realistic. Here they say, let's say x is t squared minus 1 and y is 2 times t. And they want you to go from -2 to +2. The time is between these. Okay, so here's your little table. -2 to +2. Here's x. They plugged them in and they got some numbers. Here's 2 times the times. They plugged them in and got some numbers. Zoom out a little bit. So over here, this is the book. This is page 889. This is example 1. This is 9.5, example 1. So they got these points and they plot them and they have to connect from this dot to this dot. Here's the graph. Here's the dots they came up with. And so I put the dots, but which was the first dot? The first dot was 3, -4. So here's 3, -4. The last dot was 3, +4. Here's 3, +4. Notice it's hard to see the little arrows here. They did them kind of tiny. See what they did with the arrows? They said, you're going this way. And they put another arrow here. Some people put lots of arrows, but make sure people see your arrows. So you started here, it curved upward and went like that. Hey, we got a parabola. Well, that's because of the square in this one. This could be like a satellite dish or a radar aiming sideways or a flashlight. But this one normally, you couldn't do this normally because remember vertical line test, not a function. You'll never be able to get a graph like this without using a parametric equation. So there it is. They can be used for cool things. But I'm not going to go into the rest. You can do them with cosines and sines. And it's kind of cool if you had something like this one, 5 cosine t sine. When you put this in, you can actually do some manipulation, which if we were here, we'd get into this. There's actually some trig getting involved. But as they rearrange it, this is the equation of ellipse. Isn't that the ellipse? The x radius and the y radius? But this equation is the parametric form. Let me go up here. This is the parametric form of an ellipse. You could do the ellipse not like we did it, but with trigonometry and parametrics. But that actually creates an elliptical graph. It creates this graph here. Okay, that's a traditionally, but the one we did actually only created half of the graph because, well, they said let's just go from 0 to pi. If we went 0 to 2 pi, we could get the rest of it. Kind of cool, but we're not going to get into that. But at least now you know what a parametric equation is. When you see it in calculus, you're like, oh, that's pretty easy. Just plug in some t's and get my x's and y's. That's it. Do the homework, submit it, and on Fridays our test on all this. Have fun.